Okay, today the new stuff is going to be about composition of functions, where a function goes inside of another function. Okay, it's the hardest kind, but let's start with simple stuff. Do you remember that I told you function notation was basically saying f of x instead of y? And there was an advantage. One of the advantages was that if I just said y equals this and y equals that, it would look like they are equal to each other. But these are just two different functions, and they don't have to be equal to each other. This might equal the other one, but that's a totally different thing. Okay, so moral of the story, function notation is good for that. Here's another thing function notation is good for. If I wanted to put in x equals 2, there's no way to say that by saying y like little 2 or something. But if I use function notation, I can say f of 2. Would you please find f of 2 and then add it to g of 2? I'm going to pause for a second while you give that one a try. Okay, should have said f of 2. You stick the 2 into the f function. Notice I'm going to write the f function with an empty spot where the variable is. And then I'm going to do the same thing with the g function with an empty spot where the variable is. And now I'm going to drop in what they told me. They told me to put in 2 for this one and 2 for that one. This one becomes 4 plus 4, which is 8, plus that one becomes 9 times 2 is 18, minus 1 is 17, and 8 plus 17 is 25. Raise your hand if you had 25. Okay, next. What if I asked you for 3f of 2 minus 9? See if you know how to do that kind yet. Hint, you always just do one step at a time. Find the f of 2. You should have first of all done f of 2, just one little step at a time. F of 2 is 8, and that's 8. And now 3, 8, that means 3 times 8. 3 times 8, 24, 24 minus 9. That's like 24 minus 10, but that would be 14, but it's not, you didn't subtract quite that much, so it's 15. Just trying to show you a way you could do that in your head. Raise your hand if you had that one right. Okay, good. Next, the kind where you have, instead of me telling you what to stick into the function, what if instead I don't say like stick in 2 into the f function? What if I say the f function actually is something else? Well, then you can't stick that in for x. But if you see that f of x is this and f of x is that, then this must equal that, if they're the same thing, right? And that's an equation that you can solve. Solve it. And this time, your answer will be a fraction. I want you to turn your answer my way, and I'll tell you if it's right or not. I'll pause while we do this. All right, almost everybody got this one. It was 2x plus 4 equals 6x minus 3. You have subtracted 2x from both sides, and then here's some classic mistakes people sometimes make. I have to add 3 to both sides. All it takes is to mess up one little subtract like that, and like subtract them instead of add them, and all of a sudden you get a different answer. 7 equals, and I screwed something up. It was 8x minus 3, wasn't it? All right, feel free to interrupt me when that happens so that I can fix it. All right, and then this is 6x equals 7, and then 7, 6 equals x. At least I caught my mistake, but you can see all it takes is one little oops, and the whole thing will be wrong. All right, so that's the end of like day 2 on functions. All right, now we got into the chart kind. Instead of making up a chart, it takes too long to make one. I can make a graph for you though pretty quick. See if I can find my graph that I made in a different hour. I'm going to pause while I do that. Okay, so then we had the kind that had graphs like this. All right, what if I said, what's f of 3? I hope you think of this in terms of, did he just tell me an x or did he just tell me a y? Because on a graph, you really need to go with, like the points are in x and y form. F of x is the same thing as y, right? So by saying this, did I say that x was 3 or that y was 3? X was 3. All right, if x is 3, then I can follow that over. There's where the x's are. That's where x is 3. I follow it up. That's the point 3 comma 2. I hope you get that if I write this, that's exactly the same as the point 3 comma 2. So f of 3 is 2 is what a point really means. You never learned that probably before. Yes?
Why is f of x or f of 3 like on the x side first?
Okay, hold on. Didn't you just said it. You said f of x, didn't you? By saying f of x, then you just said that x is 3. Okay? But the answer to that over here, let's say it's 2, then this part is this part where you get x, and this whole thing is f of x, which is like y, and it's saying y is 2 and x is 3. Okay, so if I take this point right here, do you get that 5 comma 0 means f of 5 is 0, and that's the x part, and that's the y part? All right. So I'm going to back up a little notch here. So do you remember me giving you the top 20 where I'd say here's a point, and here's a point, and you got to figure out like the slope between the 2 points? You know what I'm talking about? Okay. Well, I could have said those points differently. Do you guess that's exactly the same as saying the point 2 comma 5 and the point 9 comma 12? You got to get used to that. That's part of function notation, is understanding that a point 2 comma 5 can be written as f of 2 is 5. Okay, back to this. Let's say I said f of 0. What's the answer? F of 0 is what? There it is, 0 comma 5. X was 0. Here's where the 0 is on the x. You follow it up until it hits, and there it is. 0 comma 5. F of 0 is 5. All right. How about, what's f of 1? F of 1 is 3. Yep, it's right there. See this? So then they do it this way. They're telling you, hey, x is 1. Figure out what y is. What if they do it this way? They're saying, hey, y is 1. Get out, f of x is y. They're saying y is 3. And by saying y is 3, you're supposed to figure out what x is. X must be 1. I would also have accepted that f of 1 is 3, because I know that means the point 1 comma 3. All right, so f of x equals 5. Figure out first, did I tell you an x or did I tell you a y? And then figure out the other part. So on this, did I tell you x or did I tell you y? I told you y. Y is 5. Here's where y is 5. And then I go, oh, there's the point right there. And it's 0 comma 5. That also, if you're getting used to it, if you write that point out, that means f of 0 is 5. And we already have the 5 part, so they just asking me to say that x equals 0. Or f of 0 is 5. All right, one more to just see if you really got that. I'm going to give you one. This is going to be harder. It's okay. Give your best approximation for f of 2. you can figure out logically about what it is. This one's weird because you can't just say, oh, the answer is 6. So did I tell you X or Y? I basically said, hey, X is 2. So now you go over here. Here's where X is 2. And you follow it up and there's no dot there. But do you get what we're looking for is a Y value? We already have the X. We're trying to figure out this. How high is it here? Well, this guy that's above it had a Y value of 3. The one below it had a Y value of 2. How many of you said it was like 2.5-ish? All right, nice job. Cool. And now the hardest kind of them all, and the last thing I got to review with you of what you learned before this. What if I say f of 3x minus 9 is equal to 0? Whoa. Who remembers what I did to simplify the problem? Because I always say just do one thing at a time, right? Remember what I did? I did not. You might think I did, but I didn't. Not yet. There's a thing I'm going to do first, and then I will eventually divide by 3. But there's something else I do first. Yes?
Now don't you just ignore the f of x and then after 0?
You ignore this part, yes. And I scribbled it out. I recommend you do that too. You can take that erasing off later when when you want to see it again. But what do you mean, Mr. Server? I'm simplifying it to just say f of what is 0. That's a simple question. I can answer that first. What point is this? F of what is what? F of 5 is 0. So right there. So this part has to be 5. So can I just say the answer is 5? No, because what's underneath there needs to equal 5. What's underneath the scribbly thing must be 5, but it's not. It's an equation thing, so I set up an equation. That is equal to whatever's under there. So what is under there? And then I have the equation. 3x minus 9 equals 5. See what I'm saying? F of something is 0. That's the easy thing. That must be 5. So if what's underneath the scribble must be 5, the equation for that is 3x minus 9 is under the scribble, must equal 5. And then I'm going to add 9. 3x equals 14. Divide by 3. 14 thirds. Raise your hand if you had 14 thirds. Okay, good. So I'm going to give you another one like that, except not walk you through it. Let's see if you can get it by yourself. F of x plus 12 is equal to 2. Yes?
The last one was 5 and 14 thirds your answer?
Nope.
Just 14.
Because the reason is if you actually stick 5 into the x, it wouldn't have worked. So just the 14 thirds would have been your only answer. But I'm glad you know that there was a first step was to get 5. So on this one, what's the first step? What have I done for this kind? Those of you that have lost your little card thingy, if you could get it out or make a new one up here. I have the cards. I have a pen. In this class, it's light blue. It's really helping me to learn your names. I'm up to about 40% of the kids. In this hour, I'm a little weaker than that. I started in my first and second hour, but okay. F of what is 2? Sam?
I think it's 9.
Just hold on. I think that's the final answer. F of what right here gives me 2. F of 3 is 2. I'm going to write that. F of 3 is 2. I can prove it because there's a point right there, 3 comma 2. Cool. Now what's underneath the scribble has to be 3. So what is underneath the scribble? X plus 12 has to be 3. these are equal to each other. And then you're right, x must be 9. Wait, no, 9 plus 12? No. I'm going to go subtract 12, and x equals negative 9. There we go. Negative 9 is my final answer. All right, those are tough. I get that those are tough. But at some point it's going to click and you're going to go, oh, God, I finally get this now. But I hope that the key for you will always be to cross off what's in that little blank and try to just find a point. Anybody can find a point. And then you're just one step away. You got to take what's in here and say equals that, and you'll have your equation to solve. All right, so what's new for today? Everybody needs to find the Smart Notebook for today, which is 9-18. Look for it in the red folder. Underneath that, look for 918, and I will find that file for you. It looks like this. Now, we've already been doing this part. That's what we were doing the review part on. So now it's about using composition of functions to evaluate expressions. Whoa. Okay, composition of functions. Have you heard of a composite before? If I had a composite tennis racket, do you have any idea what that means? Composite is a mixture of a couple things. Okay, like let's say on a tennis racket, I know for a while anyway, boron was a really good metal to be mixed in with your tennis racket because it's super light and super strong. Okay, so it was boron and like steel, or boron and aluminum, or they'd mix these two together. It's a composite. Okay, well, a composite function is a mix of two functions. Like, let's say I have f of x and g of x, like here. They say f of x is the absolute value of x, and g of x is just x plus 6, two nice simple functions. But what if I want to put one function inside and mix them together? All right, so here's the way I think of it. Now, you can think of it any way you want to, but I'm going to give you a framework, a way to think of this. It's kind of like the f function ate the g function. The g function is alive and whole inside the f function. You guys have heard of snakes like eating their prey. They can open their jaw up and like eat things that are ridiculously big. Like right now in the Everglades, they have a bunch of, what's the kind of snake again? I think it's pythons. Anyway, they are pythons that I'm pretty sure they're Burmese pythons, and they were released by people who had a pet snake. Thing got too big, started to scare them a little bit, or they got sick of feeding it because you got to feed them every like week or so. You got to drop another mouse in their cage or let the thing eat. So anyway, they get sick of the pet and they let it go in the swamp, figuring like, hey, I'll just set them free. But the problem is, they started to multiply out there, and now in the Everglades, which is like this huge, huge swampy area in Florida, we're talking massive, you know, like way bigger than all of Minnetonka, way bigger than it's like bigger than the whole Twin Cities area of swamp. In that swamp, there are so many of these snakes now that they have eaten almost all other wildlife. Like there's almost no rabbits or one of those little guys that look like bandits, raccoons, possums, squirrels, all that kind of stuff. It's gone. They've done counts now, like to go looking for animals to see, and they're all gone because they've been eaten by the snakes, and they have huge ones in there too. So it's gotten to be even scarier to be in the Everglades swamp, where you used to just have to be afraid of the alligators. Now you can be afraid of the pythons too. Well, one of my favorite stories about the python is where they are big, like along the Amazon. There was a guy who was out drinking one night, and he actually did. Yeah, that was an alligator. Actually, alligator just recently ate a reporter. Did you hear about that? It's actually true. He was in. He had wandered away from the other reporters and stuff and gone to this little area that was nearby, and it was known for alligators. He didn't know that, and one jumped out, grabbed him, and somebody saw it from a long ways away, and he got dragged into the water. Anyway, that was an alligator. People still are getting eaten by things like this all the time. And this one was, the guy had gotten drunk, and he fell asleep, and he was so drunk that he didn't notice that a snake started to eat him. And the snake had eaten him up, like it had opened its mouth up, and it had gotten him feet first, which is the way they like to eat their things, and it had climbed all the way up, and it got stuck on his arms because his arms were out. So dude wakes up with a snake eating him. And can you imagine, like, people have a hangover after they drink? That's like the worst hangover ever, is to be waking up to a snake having partially eaten you. They were able to save him because, you know, he hadn't been, like, squished to death or anything. The snake probably thought, oh, this is perfect. This guy's not even moving. I'll just eat him. So anyway, and his arms being stuck out saved him. Anyway, this is the F function eating the G function. So I'd like you to take the F function, which is absolute value of x, but I'm going to replace the x with an empty parenthesis. Did you notice I've been doing that the whole time? I've replaced the x's with empty parentheses. And now the F function is going to eat the G function whole. Here it is, just that part. That goes in here. That's it. The F function has eaten the G function. It's kind of a mix of both. It's a composite of two functions. It's got the absolute value from this function, and it's got the x plus 6 from that function. So it's kind of a mix of both. This moves on, I think, a little bit too quickly to this. So actually, I'm sorry, B is right here, so this is fine. We can do it backwards. This time, the G function is eating the F function. So we start with the G function, give it a great big stomach. We replace the x with first a parentheses, and then that's his stomach, and now he's going to eat the F function. What's the F function? There it is. Done. That's all you got to do. Now it's kind of got a mix of both. It's got the absolute value from the F. It's got the x plus 6 from the G. But this is different. I mean, it's totally different than the other one. All right. Now, how about this? F of G of negative 10. Well, you can do it the same way, except at the end you stick in x is negative 10. Or, I think the smarter way is, what do you think we start with? G of negative 10. We start on the inside, like on all tough math problems. You start in there, and you just do that. You don't worry about the F function until later. So first, let's just do G of negative 10. So we stick a negative 10 in the G function, and there we go, and what do we get? Negative 4. Now it's F of negative 4. And what is F of negative 4? The negative 4 into the F function, and you get 4. Absolute value of that, which is 4. Okay, I want to do another one like that. Let's say I have f of x is equal to 2x plus 5, and g of x is equal to 1 over x. First, I'd like you to figure out what's f of g of x. Make the f function eat the g function. And check with a friend sitting near you, the kid across from you. I'll pause for a second while you try that. So hopefully you're going to start with the f function, which is this guy, and give it a big empty stomach right there. 2, empty spot, plus 5. And then, what does it eat? G of x. What's g of x? There it is. Now, do you have to actually multiply that out? Well, in this case, that is about as simple as it gets. If you wanted to multiply by 2 over 1, you could call it 2 over x plus 5. But I don't know that that's really any better than what we had in the first place. So multiply them out if you can, but otherwise you can leave them. Do you get that this is the same exact thing as, let me get that out of there, as that? They're equal. Why is it 2? Some people say, why does 2 only go on top? Because 2 has a denominator of 1, doesn't it? So that's why it only goes on top. Okay, yes?
Why didn't you include the x in the f function?
All right, when I wrote the f function, every time I've ever been doing this, I start by taking this function and I replace the x right away with a what? With an empty parentheses. I was trying to be consistent on that, so right now is like I kept telling you, replace the variables with empty parentheses, and we kept saying it's going to be important later. Well, now is later. The variables have to be replaced with empty parentheses so that you can stick stuff in them. So this is the f function written as a skeleton all ready to eat something, and then we drop the g function in there, and it's 2 times 1 over x plus 5. All right, now if you got that one, or even if you didn't, maybe you learned from your mistake, try the other way around. G of f of x. Now who's eating who? I'll pause for a second while you give that one a try. You should start with the g function first because it's going to swallow the other one. So I'm going to start with this guy. Here it is. And I'm going to say 1 over empty spot. I could have said 1 over x because that's what the g function is, but I replaced the x with an empty spot. Now I'm going to put what in there? What did it swallow? F of x. And what is f of x? 2x plus 5. Final answer, 1 over 2x plus 5. Raise your hand if you got that one right. Okay, good. Now, you might have thought of it differently than I did, but as long as you get that answer, you're fine. Okay? What if they now said, oh, by the way, that x isn't x, it's a 9. I just need to put a 9 right there, and then I'd have it? See what I mean? So what if they say g of f of 9? I actually like doing it a little differently then. I like to have it be simpler because I can find f of 9 in like 2 seconds. I just stick it in right here, and what is f of 9? Well, it's 18 plus 5 is 23. Then it's g of, and what did I just figure out f of 9 was? Now it's g of 23. Now you go stick that in the other function. These are a lot easier to me because I just do it one step at a time and I start on the inside. So now the g of 23, 23 goes in there, and I get 1 over, notice, empty spot, and I drop in 23, 1/23. Would you please use these 2 functions to figure out for me what is f of g of 1? The answer will be like 1/9 or something. Just figure out what it is, compare it with the kid next to you, and see how you did. I want you to write them because you can't show them to the kid next to you if they're in your head. It's going to be a big deal to me, so jump on board. All right, so we're going to start by plugging 1 into the g function, this part right here, and that goes in there. And what is 1 over 1? 1. So inside here, you have got 1. And now it's a new problem. Emil, what's the new problem now? What of what? F of 1. So all you got to do is stick the 1 in the right spot. And what did you get now? 2 times 1 plus 5 is 7. You are correct. Raise your hand if you had 7 for that. Okay, good. There you go. That's a function inside another function. That is a complicated concept. Function of a function. But that's the homework for tonight. Now, the only thing they can throw at you that is like maybe you're going to have to do the one function by looking at a graph, you know, like that kind. And then the other function you might have to do by looking at a table. you know, so that's how they can maybe make this a little more complicated. But all right, your homework's going to be just like that. So let's do one that's got the table on it, just so we can finish up with that, kind of remind you how that works. To start with, one step at a time. What's the easy thing we could do to make it simpler? G of 5. So let's find G of 5. Everybody use the chart over there. Figure out what G of 5 has to be. G of x is 5 makes what? Negative 4. Here's your answer right there. So now I have negative 4 right here. And what do I do to it? Square it. If you just take math one step at a time, it's not that bad. Okay, step by step. Negative 4 squared. Is it in parentheses? It matters. Yes, so then it's negative 4 times negative 4, which is positive 16. All right. I'd like you to finish B, C, D, and E, those 4, and write them down. I will check you in a moment. This is going to be like a little mini quiz to see if you're on top of this or not. Just write your answers down so that somebody else can grade them. I'll be pausing for a second. Okay, let's see how you did. First one, G of negative 1. Here's G of negative 1. I'm going to move this one up here, and I get 5. Raise your hand if you had a 5 on the inside. Then it's F of 5, because that's 5. And what's F of 5? Here's the F. Hold on a second. F of x is 5 gives me 2. Raise your hand if you had 2 for the final answer on that one. Awesome. Now let's save some time, and I'll call on some people. Peyton, give me a... Don't have to explain the whole thing, just final answer on C. Raise your hand if you agreed and got 3 on that one. Okay, cool. How about D as in donkey? Let's go with Andrea.
0.
Raise your hand if you also got 0 for that one. And that's pretty much everybody. Excellent. And now, Katie, what'd you get for the last one? All right, then let's walk through it together. What's G of negative 1? That's first. So do you see what G of negative 1 is? Got it? Yep. What is it?
5.
Yes. So now what? G of 5. G of 5. Negative 4 is right. Who had negative 4 for that last one? Okay, good. All right, cool. I think you get everything that you need to get. Now, we don't need to do any of these for practice. I think we're good. The assignment is, there's a worksheet basically, and it's got more problems than usual. So let's definitely start that thing right away, but at least you got like 10 minutes to work right now. I know that there was some stuff due today, but I want to not take up your 10 minutes of work time dealing with that. Tomorrow's a much easier day because we did so much review today. Tomorrow we'll deal with some of the old stuff I assigned you, like version 2 of the top 20. We were supposed to do like a worksheet. If you haven't already done that, you should do that. Okay, version 2 of the top 20. It's at davidserver.com. Version 3 we did in class together already, right? If you were here on Friday, you already did that. If you missed on Friday, you can do it at home. Just do version 3. Just do it out on your iPad. It's fine. But we already did it in class. We'll grade that tomorrow because when we get more time. Any questions? Okay. Yes?
Was version 3 on paper or...
It was on paper in the classroom. But if you're gone on Friday, you can just do it at home on your iPad. I'm fine with that. You know where versions 1, 2, 3, 4, and 5 all are. They're all on that davidserver.com. Question? All right, cool. I will answer individual questions at this point. That's all I got for the video for today.